So guys, in previous video we saw about the electrophilic substitution reactions of phenols. So today in this video we are going to see certain important continuation of the same concept, that is electrophilic substitution reactions of phenols. So in this video we are mainly going to see two important named reactions. One is called as a Kolbe's reaction, another is called as a Riemer-Tiemann reaction. Basically, first let us deal with this Kolbe's reaction. So, in order to deal this Kolbe's reaction, I would just like you to recall a concept from our earlier videos. And majorly, the concept is about the manufacturing of your aspirin, or in simple terms, preparation of aspirin. So when we were preparing the aspirin, there we have utilized one important reactant or important compound. What was that compound for the manufacture of your aspirin? Recall it? Yes, salicylic acid. Do you remember that? When salicylic acid was treated with an acetic anhydride, there we have got our aspirin. In this Kolbe's reaction, today we are going to study that how that salicylic acid can be prepared. Okay, and do remember, it is coming under the concept of electrophilic substitution reaction of your phenols. So according to your syllabus, basically they have given only this much. That is what, when your phenol is treated in the presence of NaOH, then you will be getting your sodium phenoxide, ONA. Then treating the sodium phenoxide in the presence of your carbon dioxide, and on acidification you will be getting the, yes, what is that? Salicylic acid. Salicylic acid. What would be its IUPAC name? 2-hydroxy benzoic acid. 2-hydroxy benzoic acid, or it is also called as what? Salicylic acid. This is only according to your syllabus. But let us now have certain additional information about this Kolbe's reaction. Do remember guys, whatever we are seeing in this method is not such a simple task to be carried out. Of course, till here whatever we have seen, I'm just going to continue my additional information from this step onwards. Of course, whatever the sodium phenoxide you're treating, ONA, remember it's an additional information. No need of writing this part in your exam, but it will be important when you're going through your competitive exams. Okay. So first, this sodium phenoxide is treated with that of your carbon dioxide. Okay. Do remember we have to maintain a temperature of nearly 413 Kelvin temperature and nearly 6 to 7 atmospheres. Are you getting my point? So when you do that part, you will be getting a compound. That is, here you will be having your OH, here you will be having your COONA, which is called as sodium salicylate. Sodium salicylate. Then upon treating this sodium salicylate on acidification, you will be getting your corresponding salicylic acid. Are you getting my point? So this is the actual task of in the Kolbe's reaction. Of course, the first thing what we have done, you have converted your phenol to sodium phenoxide. Then we have treated that sodium phenoxide with a carbon dioxide at a temperature of nearly 413 Kelvin temperature, 6 to 7 atmospheres. On treatment, we will be getting a sodium salicylate. Treating this sodium salicylate on with HCl, or in simple words we can say on acidification, we will be getting our respective salicylic acid. Do remember one important thing. So whatever the salicylic acid we have got, it is in the ortho position. Alright, it is in ortho position. In case if you want to obtain in the para position, this 413 Kelvin temperature is very much important. If you maintain a temperature above 413 Kelvin temperature, remember, we will be getting a para isomer. Instead of ortho, we will be getting what? Para isomer. This is only possible when you are treating this one above 413 Kelvin temperature. Are you getting my part? This is the first additional information. And the second most important thing, do remember, when your OH and COOH, both groups are present, of course we know that both are acidic group. Both are having the capacity to donate your H+. But do remember, when such two acidic groups are present and going to form a respective salts, that is now we will be having a doubt. What is that? You are having now OH and also you are having now COOH. And you are going to treat this one with NaOH. Of course, we know both are acid, it is going to react with the base. But the question arises whether the formed compound will be having ONA or COONA. ಅಲ್ವಾ? ಎರಡು acidic group ಆದರೆ ಯಾವುದು ಒಂದ್ರ ಜೊತೆ ಮಾತ್ರ ರಿಯಾಕ್ಟ್ ಆಗಬೇಕು. ಅದು ಯಾವುದು ಅನ್ನೋ ಕ್ವಶನ್ ಮಾರ್ಕ್ ಬರುತ್ತೆ. Do remember, in those cases, the group which is more acidic, I repeat, the group which is more acidic will be forming the respective sodium salt. That is, we would be getting as what? Yeah, here you will be having your OH group as it is. More acidic is your COOH group, so it will be forming your respective sodium salt of carboxylic acid, COO minus Na plus. Is that clear? So what are the additional information we came to know? That whatever the sodium phenoxide, you are going to treat it with the carbon dioxide, we are maintaining a temperature of nearly equal to 413 Kelvin temperature and nearly 6 to 7 atmospheres. In that case, we will be getting a compound which is called as sodium salicylate. On acidification of this sodium salicylate, we will be getting our respective salicylic acid. But in case if you are maintaining the temperature above 413 Kelvin temperature, what happens? Instead of an ortho product, we will be getting a para isomer. Okay. And the next most important thing, in case if you are having the two acidic groups attached, remember, on treating it with a respective base, you will be getting a salt from the group which will be more acidic. Is that clear? Further things. Of course, sir, you said that Kolbe's reaction is an electrophile. Otherwise, it's an electrophilic substitution reaction. When we saw nitration, we came to know there our NO2 was acting as an electrophile. When we thought about bromination, there we got to know that our Br plus was acting as an electrophile. But sir, how can you say in Kolbe's reaction which is your electrophile? I repeat, now your question is, in this Kolbe's reaction, which is your electrophile? Do remember, guys, our CO2 itself is an electrophile. Our CO2 itself is an electrophile. Why is it so? Because when we write its structure, of course, having a linear structure, due to the electronegative nature of your oxygen is more, your carbon will be having some delta positive charge. So utilizing this positive charge, your CO2 acts as an electrophile. And do remember, whatever the electrophile we are saying as a CO2, it is a weak electrophile. What it is? It is a weak electrophile. Hence, we are studying this reaction under your electrophilic substitution reaction of phenols. But once again, if you are making a close observation, we can see one important thing. What is that? Okay, so we are reading about electrophilic substitution reaction of phenols. But what we are doing in the reaction, we are treating our carbon dioxide not with the phenol, but with, yes, sodium phenoxide. Question arises, why is it so? Remember, guys, as we are saying that CO2 is an electrophile, or any electrophile it could be. It will only attach to the benzene ring when its electron density will be higher. And do remember, when we compare the OH and that of your ONA, remember, ONA's reactivity towards the electrophilic substitution reaction is more. I repeat, sodium phenoxide's reactivity towards the electrophilic substitution reaction is more. Once again, the question arises, why? Because the electron donating tendency of your hydroxy group, I repeat, the electron donating tendency of your hydroxy group is less. What is it? It is less when compared to the electron donating tendency of your ONA. So ONA ಏನ್ ಮಾಡುತ್ತೆ, ಬೇಗನೆ ಎಲೆಕ್ಟ್ರಾನ್ ಕೊಡುತ್ತೆ. ಅವಾಗ ಏನಾಗುತ್ತೆ, ಎಲೆಕ್ಟ್ರಾನ್ ಡೆನ್ಸಿಟಿ ಬೇಗನೆ ಬೆನ್ಸಿನ್ ರಿಂಗ್ ಮೇಲೆ ಬಂದ್ಬಿಡುತ್ತೆ. Are you getting my point? ಆ ರೀಸನ್ ಇಂದ ನಾವೇನ್ ಹೇಳ್ತೀವಿ, your sodium phenoxide is highly reactive. ಚಾನ್ಸಸ್ ಉಂಟು CO2 ಕೂಡ ನಿಮ್ಮ OH ಜೊತೆ ಟ್ರೀಟ್ ಮಾಡಬಹುದು. ಆದ್ರೆ ಏನಾಗುತ್ತೆ, ಸಿನ್ಸ್ ಇಟ್ ಇಸ್ ಆಲ್ ಅಬೌಟ್ ಇನ್ ಇಂಡಸ್ಟ್ರಿಯಲ್ ಪಾರ್ಟ್, ನಮ್ಗೆ ಅತಿ ಬೇಗನೂ ಆಗ್ಬೇಕು, ಕಮ್ಮಿನೂ ನಮ್ಗೆ ಕಾಸ್ಟ್ ಆಗಿರ್ಬೇಕು. ಸೊ ಇಟ್ ಇಸ್ ಓನ್ಲಿ ಪಾಸಿಬಲ್ when we are talking about or converting your phenol to that of your phenoxide. Is that clear? That is the reason. Two important things one has to know when you're reading about your Kolbe's reaction. What is that? First, we have to convert our phenol to that of your phenoxide. It is by treating with that of your NaOH. Then we have to treat that sodium phenoxide with respect to that of your CO2, and upon acidification, this is very much important, and then upon acidification we will be getting our salicylic acid. As an additional information, what we came to know here, whatever electrophile is there, it is your CO2, which is a weak electrophile. And the second most important thing we have to remember, the reactivity. The reactivity of your sodium phenoxide is more when compared to the reactivity of your respective phenols. Is that clear? Very much important, since it is a named reaction we came to know, which is called as what? Kolbe's reaction. So in this reaction we are seeing that how one can manufacture or prepare your salicylic acid, or in IUPAC terms 2-hydroxybenzoic acid. Next we are going to see another important named reaction, which is called as Riemer-Tiemann reaction. Okay, so now let us see the next important reaction, which is called as Riemer-Tiemann reaction. Riemer-Tiemann reaction. So before starting this reaction, I would just like to make you one thing clear, guys. So here you're going to see a fact, or you're going to study about a thing, a small concept of called as carbene. Okay, called as what? Carbene. Why I'm saying this? Because in this Riemer-Tiemann reaction we are going to see an electrophile. Okay, because it's an electrophilic substitution reaction, we have to know which is your electrophile. So when I'm talking about the electrophile, there I will be using the word as what? Carbene. So in order not to confuse you, first only I am saying that you will be having the word which I am going to say what is it after seeing the reaction. But do remember, I am going to use the word known as what? Carbene. Is that clear? Okay. Now first of all, let us study about this Riemer-Tiemann reaction. So what does it say? So basically, when your phenol is treated with chloroform CHCl3 in the presence of NaOH, in the presence of your NaOH, first you are going to get an intermediate. First we will be getting an intermediate. Let us see first of all what is that intermediate is. So of course now here you will be having as a O minus Na plus, and here you will be having as what? CHCl2. So this intermediate is called as what? Benzyl chloride. Benzyl chloride. So once again treating this one with an alkali, that is your NaOH, what happens? So here you will be having as it is O minus Na plus, but this CHCl2 will be get converted to that of your aldehyde. Okay, then upon acidification we will be getting a compound which is called as salicylaldehyde. Are you getting my point? What it is called as? Salicylaldehyde. Very much important part. So also can be called as what? 2-hydroxybenzaldehyde. Alva, 2-hydroxybenzaldehyde. Very much important, because in Kolbe's we saw about how can we prepare salicylic acid. I repeat, in Kolbe's we are getting the preparation of salicylic acid. In Riemer-Tiemann reaction we are studying about the preparation of salicylaldehyde. So in Kolbe's ಅಲ್ಲಿ ಏನಾಗಿತ್ತು, ಇಲ್ಲಿ ನಿಮಗೆ COOH ಗ್ರೂಪ್ ಇತ್ತು, ಆದರೆ Riemer-Tiemann reaction ಅಲ್ಲಿ ಆ COH ಗ್ರೂಪ್ ಬದಲು ನಿಮಗೆ ಏನುಂಟು? Yes, aldehyde group untu. Hence it has got the name as what? Salicylaldehyde. Is that clear? But the question arises over here. Of course, so we came to know that whatever we are preparing is your salicylaldehyde. But the question is, what is your electrophile over here? I repeat, what is your electrophile over here? Do remember, guys, this whatever I have taken, you just remember I have not written CHCl3 comma NaOH. Instead of that, what I have written CHCl3 plus NaOH. That means what? These two are reacting, and of course whatever the product they are going to form, alwa, that itself is acting as your electrophile. Is that clear? So now let us see what is that electrophile is basically. So whenever your chloroform, whenever our chloroform is treated with that of your OH minus, let me take as from NaOH, it will be giving you first CCl3. Okay, and once again now this will be giving you CCl2 plus Cl minus. So this part is the electrophile which is needed by us. Electrophile. Are you getting my point? So this is called as what? Your dichlorocarbene. Dichlorocarbene. So CCl2 with 2 electrons is the electrophile generated when your chloroform is treated with that of your NaOH, and that is acting as an electrophile in your Riemer-Tiemann reaction. Is that clear? Very much important. So now let us first know, what do you mean by this carbene? So basically carbene means it's a structure in which your carbon will be having it will be acting as a neutral atom. I repeat, it's a structure in which your carbon will be acting as a neutral atom, and on top of that, it will be having the two unpaired electrons. Is that clear? It is not being paired up. Are you getting my point? It is having what? 2 valence electrons as it is, and it will be bonded with 2 other moieties. Are you getting my point? So such a structure is called as what? Carbene anta heltivi. Since we can see that it is totally having 1, 2, 3, 4, 5, 6, only 6 electrons, it is in the need of more 2 electrons. It is in the need of more 2 electrons, and hence your carbene will be acting as what? Yeah, as an electrophile. As an electrophile in this case. In a Riemer-Tiemann reaction, the main important electrophile is your dichlorocarbene, which is having the formula as what? CCl2 with 2 electrons. Very much important when you write the structure of your carbene. So in a Riemer-Tiemann reaction, what it is saying? Whenever phenol is treated with a chloroform in the presence of NaOH, first it forms an intermediate which is called as what? Benzyl chloride, which upon acid hydrolysis, it will be giving you what? Salicylaldehyde. And we also came to know in a Riemer-Tiemann reaction, yes, the important electrophile generated is your dichlorocarbene. So how this dichlorocarbene is obtained? When chloroform is treated with that of your NaOH, whatever the product we are obtaining itself will be acting as an electrophile which is called as your dichlorocarbene. Is that clear? Very much important concept. Okay. So next, soon after we have seen this Kolbe's reaction and Riemer-Tiemann reaction, the next important reaction is a simple reaction. So whenever your phenol, whenever the phenol is treated with a zinc dust, whenever your phenol is treated with a zinc dust, remember we will be getting our benzene. We will be getting our benzene plus zinc oxide. So basically they can ask you what happens when phenol is treated with a zinc dust. Or certain times they will be seeing this will be coming under the concept of with zinc dust. What happens when your phenol is treated with zinc dust? Nothing happens much more. Your phenol will be getting out, and whatever the remaining part will be there, that is your benzene will be obtained. Alva ee H namge gottu. Naವೇನು ಅಂತ ಬರೆಯಬಹುದು? C6H5OH ಅಂತ ಬರೆದಿರ್ತೀವಿ ಪ್ಲಸ್ ZN. ಬೆಂಜೀನ್ ಆಗ್ಬೇಕಂದ್ರೆ ಏನಾಗಬೇಕು? C6H6 ಆಗ್ಬೇಕು. ಸೊ ಅವಾಗ ಈ H ಏನಾಗುತ್ತೆ? ತಗೊಳುತ್ತೆ. ಅವಾಗ ಏನಾಯ್ತು? C6H6 ಆಯ್ತು. ಇನ್ನೇನು ಉಳಿತು? O ಉಳಿತು. ದಟ್ ಇಸ್ ಕಮಿಂಗ್ ವಿತ್ ಯೋರ್ zinc, that is zinc oxide. Are you getting my point? So whenever your phenol is treated with zinc, it will be forming your benzene. Next, let us see an important reaction which is called as oxidation of phenol or oxidation reactions of phenol. Do remember guys, whenever your phenol is treated with chromic acid ಅಂತ ಹೇಳ್ತಾರೆ H2CrO4 which is called as what? Chromic acid. So whenever your phenol is treated with chromic acid ಬರೆಯೋಕ್ಕಿಂತ ಬದಲು ನಾನು ಏನು ಬರೀತೀನಿ Na2Cr2O7 and H2SO4 ಒಟ್ಟಿಗೆ ತಗೊಂತಾ ಇದೀವಿ. So what you are going to get? Yes, this is an important product which is called as what? Benzoquinone. You just see the structure. What it is called as what? Benzoquinone. You can ask me now, sir, of course you said about chromic acid, but here we have not seen any chromic acid which is having this formula. Alva, do remember, when your Na2Cr2O7, that is your sodium chromate, whenever it is treated with your H2SO4, yes, you will be getting your H2CrO4. So instead of writing directly as H2Cr4, in most of the cases in your competitive exams they can give you as Na2Cr2O7 and H2SO4. So you should come to know. So when your sodium chromate is treated with a sulfuric acid, it is generating what? Chromic acid. Since chromic acid, what it will try to do? It will try to facilitate your oxidation reactions. So when such a phenol is treated with such a chromic acid, the product will be obtained is called as what? Benzoquinone. Similarly, whenever we are talking about the phenol, we'll just talk about the general oxidation, that is in the presence of oxygen. Of course, here also you are going to get your benzoquinone itself. Double bond O. But it will not stop over here. Once again, what it will try to do, this benzoquinone form, it will once again try to react with that of your phenol which is present. OH plus this benzophenone, double bond O, yes, plus that of your OH which is present in your system. ಏನ್ ಸಿಸ್ಟಮ್ ಅಲ್ಲಿ OH ಇರುತ್ತಲ್ಲ, ಈ ಬೆನ್ಸೋಕ್ವಿನೋನ್ ಏನ್ ಫಾರ್ಮ್ ಆಗಿರುತ್ತೆ, once again it is reacting with that of your phenols. So there it is giving you a polymerized product. ಏನ್ ಕೊಡುತ್ತದು? A polymerized product. Generally we write it in this way. Your OH, O, double bond O, H and an O. So polymer ಕೊಡುತ್ತೆ, which is called as what? Phenoquinone ಅಂತ ಹೇಳ್ತೀವಿ. Overall structure ನಾವೇನಂತ ಹೇಳ್ತೀವಿ? Phenoquinone. And generally they are having a brilliant red compound. It's an information, so that should come to know. ಯಾವಾಗಲೇ ಆಗಲಿ ನಾವು whenever we are talking about the phenol, so whenever this phenol is treated with that of your oxygen, of course it is going to give oxidation ಆದ್ಕೂಲೆ phenol ಕೊಡೋದು ನಿಮಗೆ benzoquinone. But since this quinone is a conjugate, one more important thing. When you talk about this quinone, generally remember it's a conjugated system. Double bond, single bond, double bond, single bond, double bond, single bond, double bond. Adra alternate double, single bond untu. And hence it is a colored compound. ಆ ರೀಸನ್ ಇಂದನೇ ಫಿನಾಲ್ ನ ನೀವು ಯಾವತ್ತೇ ನಿಮ್ಮ ಒಂದು ಅಟ್ಮಾಸ್ಫಿಯರಿಕ್ ಆಕ್ಸಿಜನ್ ಗೆ ಎಕ್ಸ್ಪೋಸ್ ಮಾಡ್ತೀರಾ ಅಂದ್ಕೊಳ್ಳೆ, all of a sudden it will develop a brown color. The only reason is what? Because it is forming your benzoquinone. Very much important part one has to know. As soon as your phenol is getting oxidized, means it comes to strike to your brain that your phenol is getting converted to that of your benzoquinone. Since your benzoquinone is having such a conjugated system, remember such ಯಾವತ್ತೇ ಒಂದು compound ಈ ತರ conjugated system ಉಂಟು ಅಂದ್ರೆ most of the cases they will be colored compounds, because they will be having the high energy to absorb the radiations. So radiations absorb ಮಾಡಿ emit ಮಾಡೋ ಕಲರ್ ಏನಾಗಿರುತ್ತೆ ಅಂದ್ರೆ ನಮ್ಮ naked eye visible ಸ್ಪೆಕ್ಟ್ರದಲ್ಲಿ ಬೀಳುತ್ತೆ. Of course visible ಸ್ಪೆಕ್ಟ್ರದಲ್ಲಿ ಬೀಳ್ತಾ ಅಂದ್ರೆ ಅರ್ಥ ಏನು? That will be visible to our naked eye. Hence that is the reason we say that whenever your phenol is oxidized, generally they will be brown in color. The only reason is because they are going to form on oxidation your benzoquinone. Is that clear? So in today's video we have understood about the four important electrophilic substitution reactions. First, the Kolbe's reaction. There we have seen how to prepare your salicylic acid from your phenols. Okay. Then we came to know about Riemer reaction. There we have seen about the preparation of your salicyl aldehyde from your phenol. Then we came to know that whenever your phenol is treated with a zinc dust, it is going to give you the benzene. But when the same phenol is oxidized in the presence of oxygen or your chromic acid, we are going to get what? Benzoquinone. From the Kolbe's reaction, we also came to know that an additional information. What was that? We had to maintain a particular temperature of nearly 413 Kelvin. Otherwise, in case if you are going to exceed the temperature, you will be getting a para isomer. And more importantly, we also came to know an additional information that your CO2 acts as a weak electrophile. Compared to the phenol and phenoxide ion, your phenoxide is more reactive towards the electrophilic substitution reaction. The only reason is because your sodium phenoxide, the phenoxide ion, is having the greater tendency to donate the electron towards your benzene ring. Okay. In the Riemer reaction, we came to know that the electrophile generated in your Riemer reaction by the reaction of chloroform and that of your NaOH is called as what? Dichlorocarbon. Okay, dichlorocarbon. That is acting as an electrophile in your Riemer reaction. Is that clear? Very much important concept and two important named reactions we have come across. So you should make a note of it. Okay, very much important. Anyone can come in your exam. 100% question it is. Is that clear? So in our next video, we are going to see the leftover topic. What is that? We have seen alcohols, we have seen phenols. In the next video, we are going to talk about your ethers. We are going to talk about your ethers. Okay.